There's a technique that you can use to create the contour lines because when we get the map from the municipality, we don't actually see the lines on the map. However, we get these numbers. Uh, and I'm going to show you an sample here. That's the view of an actual map, and you see that there are lots of numbers like that, like 133.92, 133.31, stuff like that. And these are the levels of these points that are read by engineers using the leveling instrument and leveling code. And these numbers indicate the levels of these points from the sea level. So we can assume that the sea level is 0, and every time we do that reading, we are measuring its height from the surface of the sea. So we can say that this point is 134 meters, 0.47 centimeters higher than the surface of the sea level. And as you can see here, since this is an urban environment and these are the buildings, these round-shaped sideways P letters they indicate the trees, and these are the one-story buildings like garage or storage buildings that are built in the garden of these separated buildings, and this is the road. Engineers read the points where they can step in, like where they are on the road or when they enter the gardens of these plots. There is a technique that we can use here. Let's say that we have this portion of the map, and we have these numbers. This is the drawing that I asked you to print on Sunday, so that on Monday on our course, we are going to do this as our 25th and 25th exercise. So you can see that this is the building, this is our plot area, and these are the garden walls, and this is the garden. There are two sidewalks or walkways that connects these terrace areas, and there is a roof, a flat roof, and a sloping roof, and there are neighbor buildings. Here, these are separated neighbor buildings which have their own gardens, and A represents the positions of the trees, and there is the sidewalk here next to these two roads. We know that that's the north direction, and when we look to the east side, we see that there are neighbor buildings which are adjacent this time to each other and to the sidewalk here. And at their back, there are garden areas. And here on the west side, it's just a park area. After this sidewalk, it's a park area. And we see those numbers read by engineers here. Since these are buildings, they just step in the back garden and read the level, which is 71 meters, 0.86 centimeters at this point, and it goes like that. This is an empty plot. It doesn't have any buildings there, and they read some levels on the sidewalks and in these gardens and in this park area. So if we want to create the contour lines, if we want to find out the positions of the contour lines, we need to figure out we need to first understand the numbers, and we need to find 1 meter each meter height of each meter, something like this. We can say that when we see 71.53, we know that this point here is above the sea level, there is this difference, height difference, 71 meters, 53 centimeters. Again, this point is 71 meters, 86 centimeters. However, when we go towards this direction, we see that it's 70 meters point 24 centimeters. So we need to find out where is the 71 meter 00 level. It needs to be somewhere between these two dots, and it needs to be somewhere between these two dots, right? We can, and obviously, there are 3 meters, approximately 3 meters between these two dots. So we can do something like this. You can, with a freehand drawing, you can create this line that connects these two dots. And we know that since this dot is 68 meters, 78 centimeters, and this dot is 71 meters, 53 centimeters, there needs to be a 69 meter 00 point somewhere here, and 70 meter 00 point somewhere here, and there should be a 71 00 point somewhere here. So I can just divide this line into 3 parts. I don't need to measure it. It doesn't need to be a precise division. I can just trust my eye here and put these cross marks. This first one represents the 7100 level. This will represent the 7000 level, and this is the 16900 level. And I am going to do this one more time. When I combine these two dots, I know that there should be a 7100 level in between. And I can assume that since this is almost 71, it's 70 meters, 89 centimeters. So I can assume this 7100 level should be closer to that point, that end. So I put another cross line, and I see another 70.24 point level here. So I do the combination and assume that the 7100 is in between. When I find these 3 or 2, at least 2 crosses, 2 points, I can combine them with a different color pencil. It can be a freehand drawing and a curved line like this, and I can write 71 for this first contour line. This is our first contour line, and we need to keep doing the same thing. Since we find the 71 contour line, we are going to find now the 70.00 contour line. The next one, we need to figure out, I found this first line, so I need to do the same thing here. I need to combine these two lines and assume that this can be 70.00, this can be 69.00. Again, since this is 69.08 and since this is 70.12, when I combine them, there should be only one dot, which indicates the 70.00. Again, the same thing here, and this time I will have 4 points, which I need to combine. It's just a freehand drawing. It doesn't matter. It can be just something like this. It doesn't have to be like that precisely. I am just using my hand and my eye. I'm trusting my eye, and I'm trying to combine these dots. That's all. There's no rule for that. And all right, 70. That's the 70.00 meter contour line. And I keep doing that. I'm looking for 96.00. So I will have these dots I combine them and put 69 here, and I will keep doing that. I will have a 68. I will have a 67 like this. And when I try to find 66, it appears like that. However, when I look at this part of the map, I realize that there is a change of the slope. It starts to go upwards again. How this can happen? Uh, it was sloping at this direction, moving downwards. So what happened here? We can assume that how this can happen. Since we are looking a part of that map, we are not seeing the whole picture. We are focusing on a certain part of the map. We need to take a step back. It's probably something like this. After the slope ends, here that creates a kind of a small valley, it starts to raise up again like this here. It raises up a little bit, so there is a small valley here. So I need to change my direction again. It means that when I combine these two points, I will have another 66 level. When we combine them, we will have another 67 level. And when we zoom a little bit and try to see the big picture, we can realize that these lines are somehow, somewhere turns like this, and they are actually the same lines. They are both 66 because they are the parts of the same line. I'm just looking it in a zoomed way. So I think that they are separated lines. However, they are not. They are just turning like this. And again, this is the same part, same line, just two portions of it. So that's why we have two 66s and two 67s like this. And just let's look at this part of the map now. We know that there is this road, and we see these contour lines. However, in a road, it cannot be like this. These contour lines cannot be like that. They need to be in an equal position. There should be equal gaps between them. Otherwise, the slope of the road cannot be like this. However, we want it to be like this. It shouldn't be like that, because if we do that, the cars cannot move on this road. So we need to make a revision on these red lines. And now, if we are working with our hand, we can fix a sketch paper over these red lines and over this map, and find another colored pencil. It can be like green or blue, something. And we are going to do a revision with by copying these red lines. However, when we are doing that copying, there are three rules. Contour lines must be equally distributed along a road. Again, I don't need to measure anything. I'm not using any of my rulers, set squares, or T-squares. I am just trusting my eye and doing a freehand work here. And here, there is a very interesting thing along this road. This cannot happen. As you can see here, there are 2 meter differences on this road, and it's not correct. There cannot be a difference like this. The road surface, this surface of the road should be positioned like that. Otherwise, cars cannot move along. When we have a section here like this, we will see that this sidewalk is here, and then it raises 1 meter, and it raises to another meter, and there is the sidewalk here, and it's impossible for a car to be like that. So there should be a problem with the contour lines. That's why we are revising it. It cannot be like that, obviously. So there is the other rule, the second rule: contour lines must be perpendicular to roads and sidewalks. So we are going to do these revisions, and there is this third rule that we need to consider. When the contour lines are being created, they cannot overpass the buildings like this. As you can see here, or in this example, there are two contour lines that overpasses a building. It's not correct. We shouldn't do that, since each contour line represents a 1 meter height between these levels. Let's imagine that we are trying to position a building over these contour lines or this sloped surface. When we do that, it's either we need to fill the beneath the beneath surface of the building, or we can either excavate this area like this, and there appears a 3 meter high earth surface, and we can bury the some portion of the building like this. We can either have two options. So that's that will be very easy for us if we revise these contour lines when we are doing a site model. It will be very easy for us. So we need to either change direction of these contour lines. They need to follow the edges, borders of the building, either in this direction or in this direction. If we do that, it will be something like this, creating something like this. So there shouldn't be a contour line overpassing the building, because when we do the building, when we construct the building in its original place, first we need to excavate that area, and we can change all the slope, and there cannot be any contour lines like this. So we need to do these three revisions. First, the first one is the contour lines must be equally distributed along a road. The second rule is contour lines must be perpendicular to roads and sidewalks. The third one is contour lines must not overpass buildings. So let's fix a sketch paper over our map and find another pen with a different color, and we are going to copy certain parts of these red lines, and we are going to change them according to these three rules. First, let's do this. When the contour line is in a garden, it can follow our new line, can follow the red ones. There's no problem. But when we hit a sidewalk or a road, we need to do a perpendicular line. It should be perpendicular to road and sidewalk. So here I made a revision, and when I pass to the other side of the street, I find there are two buildings, and since this contour line overpasses a building, it's wrong. I need to either follow the upper edge or the bottom edge of this building. Since it's closer to the upper edge, the north edge, I choose that one, and I follow the building edge and go downwards. And again, in the garden, this is a garden area. In the garden, I just follow the red one, and this is the first revision. And I will keep doing this for the rest of the contour lines. However, like the seventh one, I just follow the red line because I'm in the garden here, and when I hit the building, I prefer this edge of the building to follow. It's the east edge, it's the closer edge. And again, when I'm in the garden, I follow the line. And when I hit the sidewalk here, I cannot just make a perpendicular pass over the street because I need to distribute the lines equally as much as possible. So this is how I do that. Between these 2 points, there should be 2 lines. So by trusting my eye, I am trying to see this imaginary line and try to divide it in 3 equal pieces. The first one appears here and the second one appears here. So this is how I'm going to do that. For this 7th line, I am going to move towards north direction, find the spot, and overpass the road perpendicularly from this spot, and then I hit the building, and I cannot overpass the building because because of the rule, the third rule. I need to go sideways. I need to follow the edge of the building, and since this is a garden area, I can again move, follow the red line. And let's do one more here, 69. For the 69, again, I start with with a garden area, so I'm just following the red line. And when I hit the building, I prefer this edge to follow. It's closer, it's the west edge. I just follow this part. Again, I'm in the garden. I follow the red line. This time I'm in my building, and there's this terrace area. Again, I follow the edge of that terrace area. In the garden, I follow the red line. However, when I hit the road, I need to go downwards to the south direction to find the position of this point, and then do a perpendicular pass. And when I do that, there is this building. I can follow its side like this. And when I'm in the garden, again, I'm following the red line. I will do the same like that. However, how this can happen, there are 3 meter difference between these 2 points. It's so close, it's so narrow. How this can happen? I need to create a 3 meter difference. This is the 66, this is the 67, and this is the 68. So it cannot be like this. It's probably something like this, because in a very narrow position, in very narrow area, 3 contour lines means that there is a huge level difference between these 2 close points. So it can either be a retaining wall like this to hold the earth to collapse, or there can be some other solutions like this. This is, I don't know what it is called in English, but in Turkish we call this a shev. Shev is this very high, steep, sloping surface. It can either be a retaining wall or a shev like that. So and when I look down, I see a garden wall like this. So probably it's a retaining wall. And when I cut through here, I will see it like this. The level of the earth here on this side is here, and on this side there is a 3 meter high level difference. So there should be a retaining wall like this to hold the earth collapsing down. And when people walk on this sidewalk, they are 3 meters higher than the surface of this park area, green area. So I prefer following the side of the retaining wall for my 68th contour line. It goes like this, and I just pass perpendicularly at this point over this road. And when I'm on the garden, I just follow the red line, and I again do a perpendicular pass and keep going like that. And my 68th a seventh line will overlap with my 68th line, so that when I do the section, this is how it will appear. There will be a perpendicular surface like this between these two levels, right? And I am going to do one more so that there will be 3 meter differences between these two surfaces, 1 meter here, 1 meter here. This is the upper surface of the sidewalk. This is the upper surface of the green area. So next to the retaining wall, I just follow the same line with 68. And when I'm on the park area again, I follow the red line, and I just pass the road perpendicularly. This is my 67th contour line. And for the 66th, again, next to the retaining wall, I will follow the same line. And once I'm on the park, I will follow the red line. This is the 66th. And again, since this is a park area, I will just follow the red lines here. And that's all the revisions that I need to do. However, because these lines are not real, there are no difference like this. In reality, these are some imaginary lines that we created to understand the slope. We need to draw them with dashed lines. That's the line type that we prefer if something is not real or if there is something that we cannot see. So I need to convert them to dashed lines when I'm copying, and that's all. And these numbers are important. I need to write the level on both ends of each contour line so I won't get confused. And if you do that, it will be very practical for you to do a site model. The only thing that you need to do is to cut each contour line and elevate them for 1 meter by using a proper thickness, a proper thick modeling material, like a board.